This is a presentation on soft computing. Topic: solving a problem using max-min composition, presented by Professor K. Bueller-Sugandhi, Associate Professor, ECE. Welcome to my class on soft computing. In this presentation, I propose to solve a problem, an interesting problem in fuzzy logic. The student is expected to have a basic knowledge on fuzzy logic and membership functions. So this is a problem on compensation for professional engineers. The compensation for quality efforts in engineering does not have to be solely related to money. Reward structure can be public compliments, good raise, etc. And desired professional behavior can be hard work, good manners, and high productivity. The management perceptions can be whether the engineer is nice to have around and whether he makes the boss look good. The statement of the problem. Given the relation matrices of membership functions relating management perception and engineer's behavior RPB and relating reward and management perception RRP, we need to compute the relationship between reward and engineer's behavior RRB. This can be done using max-min composition. Given the matrices B, P and R, engineer's behavior B equal to hard work, HW, good manners, GM and high productivity, HP. Management perception P has two attributes, nice to have around in HA and makes the boss look good, MLG. Reward R has two attributes, public compliments, PC and good raise, GR. The relation matrix RPB is between perception and behavior. The membership functions for professional behavior and management perceptions can be established by engineering staff and management together through a combination of subjective judgment, consensus and normalization of possible values on the interval 0 and 1. So nice to have around has a membership function 0.2 with reference to hard work, 0.8 with reference to good manners and 0.7 with reference to high productivity, and makes the boss look good has a membership function 0.4 with reference to hard work, 0.5 with reference to good manners and 0.8 with reference to high productivity. So this shows a relation between reward and perception. The rewards are in the range 0 and 1, where 1 corresponds to maximum number of public compliments and a membership value of 1 for a good raise might correspond to 3.5%. So 1 is the maximum and 0 is the minimum. Here public compliment as a membership function of 0.5 with reference to nice to have around and 0.9 reference to makes the boss look good, and good raise will have a membership function 0.7 with reference to nice to have around and 0.8 reference to makes the boss look good. So given these two matrices, we need to find the relation between reward and behavior. So this can be done using max-min composition. This is given R of xy and S of yz. The max-min composition T of xz is given by T equal to ROS. T of xz equal to max of with reference to y of min values between R, xy and S, y, z. Now I show the relationship matrices RRP and RPB again. Now we'll see an example calculation. The resultant matrix will have a first element, that is 1, 1, as max min of RRP of p comma 1, giving the values p equal to 1 and 2. So I show the matrices RRP and RPB again. RRP has in the first row, that is 0.5 and 0.9, and RPB has first column 0.2 and 0.4. So now this RRP of 1 1 will be max min of 0.5 comma 0.2 and 0.9 comma 0.4. So the first set has a minimum value of 0.2 and the second set has minimum value of 0.4, and the maximum between these two is 0.4. So the resultant matrix, that is the relationship between reward and behavior obtained using max min composition, has the first element as 0.4. Similarly, the other elements can also be calculated using max min composition. So the result shows that for these data at any rate, it is equally possible to receive a reward through public compliments as through a good race, as we get the same membership functions in both the rows. So here is a note. Note that RPB is a 2 cross 3 matrix and RRP is a 2 cross 2 matrix. So the resultant matrix RRB is a 2 cross 3 matrix which follows general matrix multiplication rules. So let's see a similar problem. Let small integers be defined as a fuzzy set a equal to 1 comma 1, 2 comma 0.5, 3 comma 0.4 and 4 comma 0.2. Here 1, 2, 3 and 4 are the elements and 1, 0.5, 0.4 and 0.2 are the membership functions. Let fuzzy relation almost equal be defined as R such that 1, 2, 3, 4, 1, 2, 3, 4 again, 1, 0.8, 0, 0, 0.8, 1, 0, 0, 0.8, 1, 0.8 and 0, 0, 0.8, 1. I'll explain the first row alone. So 1 is equal to 1, so it is having maximum membership function 1. 1 can be almost equal to 2, that is with the membership function of 0.8. 1 cannot be equal to 3, so the membership function is 0. 1 cannot be equal to 4, so the membership function is 0. The other elements are also defined like that. So given this fuzzy set A and R, the membership function of the new fuzzy set B equal to rather small integers can be determined by max min composition B equal to AOR. It is left to the student as an exercise. So the answer can be cross-checked. B equal to 1, 0.8, 0.5 and 0.4. Thank you.